Alright, parallelograms, the first thing we need to know is that opposite sides are parallel, and that's like our first bubble. It's our first characteristic. Do you remember what the symbol for parallel looks like? Two lines that are like basically parallel to each other, right? Looks like that. Okay, that's the symbol for parallel. Opposite sides are parallels. It's like this side is parallel to that one, and we use the arrows. And then this side is parallel to that side, and I use two arrows just to show that those two are parallel and those two are the ones that are, like I said, parallel to each other. And we also have the fact that opposite sides are congruent. What's congruent mean? The same, or equal. So opposite sides are congruent, so this side is congruent to that side. And this side is congruent to this side. Opposite sides are congruent. We have opposite angles. Opposite angles are congruent. So if we draw a parallelogram here, the opposite angles are the ones that are the same. And these are going to be the same. Opposite angles are congruent. And last but not least, our fourth property of parallelograms, diagonals bisect each other. Diagonals bisect each other. If I give you a parallelogram here, the diagonals go from corner to corner like this. And yeah, like Mrs. Elsley said, they bisect each other. What's bisect mean again? They cross. How do they cross? If it's bisected, what's it do? It crosses and it does what? It splits it into two equal parts, right? The diagonals bisect, so it splits them into two equal parts. So those parts are equal, and then those two parts are equal. That's what that looks like. Those are your four properties. So here's what I'm going to kind of do. I'm going to kind of draw this liner under here because those are the properties, and then we're going to look at four examples. Yeah. So those are our four properties. Example 1, draw yourself a parallelogram. And the bigger you draw them, the easier it is. This is the y degrees, and this is like 65. This is a 65. We have x plus 4 and we have 12. So talk to me about y. If it's y degrees and 65 degrees, so are those sides or are those angles? Angles. So look up here. This is the only one that talks about angles. That talks about sides, that's sides, and that's the diagonals. This one says opposite angles are congruent. Congruent means they're equal. Opposite angles are congruent. They're equal. So we say y equals 65. That's it. Opposite angles are equal. They're congruent. And this x plus 4 and this 12, what does that refer to? Sides, angles, or diagonals? The sides. So opposite sides are parallel. We showed that. We also know opposite sides are congruent. Opposite sides are congruent. So we come down here. If these are congruent, congruent means equal. So set them equal. So we can say x plus 4 equals 12, minus 4 minus 4, x equals 8. The question is, does it make sense? If x is 8, plug 8 back in up here. What's 8 plus 4? 12. Is 12 the same as the other side? 12? Yeah, opposite sides are congruent. Example 2 here. We've got a parallelogram. This side and this side are parallel. Those sides are parallel. We've got 60 degrees here. We'll go E, F, G, and H. And this side is 8. So I'm going to say find FG. And also tell me what's the measure of angle G. So look at this and fill in the blanks yourself in your head. What is FG and what is angle G? When you know, raise your hand and tell me. Raise your hand and tell me, how big is FG? How do you know it's 8? It's parallel to the other side. Opposite sides are parallel, opposite sides are congruent. So FG is 8, very nice. And somebody else, raise your hand and tell me, how big is angle G? Dylan? Why is it 60? Why? Which one of these is it? Is it saying opposite sides are parallel? Is it saying opposite sides are congruent? Diagonals bisect each other? Opposite angles are congruent. Yeah, so I know this one's 60 because opposite angles are congruent, right? Cool. Example 3. We'll call this one 2x. And this is 18. And this is y plus 3. So what do we know about y? This is referring to a side or an angle? A side. What do we know about sides? The opposite sides are congruent. They're equal to each other. So we say y plus 3 equals 18. Solve it. Minus 3, minus 3. Y equals 15. And just double check. Does it work? If y is 15, put a 15 in here. 15 plus 3 is 18. 18 and 18 match up. Yeah, both of those sides would then be 18. And then we look at x. So, what do I know about this angle and this angle? They're opposite and they're congruent, or they're equal. Opposite angles are equal, opposite angles are congruent. So set it equal. 2x equals 50. Divide by 2. X equals 25. Does it work? 2 times 25 is 50. 50 equal to 50? Yeah. Last one. We've got parallelogram. The bigger you draw this one, the better off you're going to be. We've got diagonals in this one. We have J, K, L, M, and N in the center here. This is 2. This is 40 degrees. This whole thing is 110. And I'm going to say, let's find NM, KM, measure of angle, KJM, and the measure of angle, NJM. So here's KN, and I want to know, what is NM? What do I know? This line in here is called a, starts with a D. What's this line? It's a diagonal. What do we know about diagonals? Diagonals bisect each other. So if I say how big is NM, we know NM is, if this is 2, it's going to be congruent to this one, which is also 2. So NM is going to be 2. I can put a 2 in there. And then from K to M, this is 2, this is another 2, Km is 4. And then we get a little tricky, not super tricky, but a little bit. Watch closely on this one. I'm telling you, this whole angle in here is 110 degrees. Does that make sense? What kind of angle is 110 degrees? Right? Acute, obtuse. Obtuse. Does this appear to be an obtuse angle? Yeah. Appears to be an obtuse angle. Okay. And now I say down here, KJM. Find the measure of angle K to J to M. Is that an obtuse angle? Is that going to be 110 degrees too? No. So just by looking at it, you know this angle measuring here, it has to be less than 90 because it's acute. We okay there? Okay. So, I'm going to make you think all the way back to first trimester. If I have this transversal going through here, what do I call these kind of angles? Consecutive interior. And what's another name for consecutive interior? Same side interior. Same side interior, right? Same side are, starts with another S. Not complement. Say it. Supplementary. What's supplementary mean? They add up to 180. So check this out. These two angles add up to 180. If this one's 110 and they're supplementary, same side interior, supplementary, define angle KJM. Not 80. But how do we find out? So if this is 110, what's this one have to be if they add up to 180? This one is 110. And this one must be 180 minus 110 gives us 70 degrees. This angle here is 70 degrees. That whole thing is 70 degrees. Fill that in. This whole thing is 70. This whole thing is 110. So 70 plus 110 gives us 180. Okay? If both of these together add up to 70, now this question says, what's NJM? N to J to M. I want to know NJM. What's this angle in here? If I even call it X. The whole thing we said is 70. That's 40. How do we find that third one? Well, you could say 40 plus X equals 70. We can do that. Right? Both of those angles added together equal to 70. Well, what's X? How do we solve it? X equals 30. Subtract your 40 over and X is 30. Doesn't make sense. 40 plus 30 gives us 70 degrees. At 70 and the 110, they add up to 180. They're supplementary. That's 8.2 parallelograms. 4 properties of parallelograms.